Hi everybody. So here we've got a past exam question on a chain rule. We're told that the volume of a spherical balloon is increasing at a constant rate of 70 pi centimeters cubed per second. We need to find the rate of increase of the radius of a balloon at the instant when the radius of a balloon is 5 centimeters. So using the chain rule, do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you want to go. So we're told the volume of a spherical balloon is increasing at a constant rate of 70 pi centimeters cubed per second. So what we have here is dV by dt, and we're told this is 70 pi. We want to find the rate of increase of a radius. So we want to find dr by dt. So using the chain rule, if we have dV by dt, we need to think about what can we multiply this by to get dr by dt? Well, we multiply it by dr by dv, because can you see that these dv's will cancel, and we're left with dr over dt, which is what we have on this left-hand side. So we need to work out dr by dv. And we're told is a spherical balloon. Well, we know the volume of a sphere is 4/3 pi r cubed. So we can differentiate this with respect to r, and we'll get dv by dr. We'll multiply the 4 by the 3, we'll get 12 over 3. So this will become 4. And then we'll take away 1 from that power, and we'll get 4 pi r squared. So dr by dv will be the reciprocal of this, 1 over 4 pi r squared. And now we can substitute this back into here. So dr by dt will be the dv by dt multiplied by the 1 over 4 pi r squared. Now we can simplify this. We'll have 70 pi over 4 pi r squared. And you can see that the pi's will cancel. And with 70 over 4, we can simplify as 35 over 2. So we'll have 35 over 2 r squared. And this is dr by dt. Now what we want is the rate of change when the radius of a balloon is exactly 5 centimeters. So dr by dt, when r equals 5, will be 35 over 2 lots of the 5 squared. So we'll have 35 over 50. We'll divide both by 5, and we'll get 7/10. This will be 7/10 centimeters per second. Okay? So that's part 1. In part 2, we're going to look at solving a differential equation. So we're told that the rate of increase in the depth of water at a particular point in the cave is given by this model, where k is a constant and t is in hours. We're given these conditions, and we need to work out the time when the depth of the water is 10 centimeters. So do you want to give this question a go yourself? Remember, you'll be using separation of variables. You can pause the video and come back when you're ready. Okay, so welcome back if you want to go. So if dh by dt is k over h cubed, we need to rearrange this so all the similar variables are together. So we'll begin by multiplying both sides by the h cubed. That will move the h's on the same side. And we can move this dt to the other side. So we'll times both by dt. So we'll have h cubed dh will equal k dt. And now that the variables are on the same side, And now we can integrate both sides. The left-hand side, we're integrating with respect to h. The right-hand side, we're integrating with respect to t. So if we integrate h cubed with respect to h, we'll get 1/4 of h to the 4. And if we integrate k with respect to t, we'll get kt plus a constant. And then we're told the initial condition at t equals 0, h is equal to 4. So this will allow us to work out the constant term c. We'll substitute in the values, so we'll have 1/4 of 4 to the 4 will equal k multiplied by t plus c. So we'll have 1/4 of 4 to the power of 4. This will give us 64. The k term will go, and that will equal c. So if I write this back into the equation, 1/4 of h to the 4 will be kt plus c. And now we can use these conditions. We know t is 5 and h is 6. So we'll have 1/4 of 6 to the power of 4 will equal 5k plus the 64. So we can work out this left-hand side, and we'll have 324. And then we can take away the 64 from both sides, and we'll have 260 will equal 5k. So therefore, k will equal 52. Substituting in k, we'll have 1/4 of h to the 4 will equal 52 times t plus the 64. Now I'm just going to move this quarter to the other side. So h to the 4 will be 208t plus 256. Now we're told we want to work out the time when the depth is 10 centimeters. So I'll substitute in h equals 10. We'll have 10 to the 4, so 10,000. We'll take away the 256 from both sides, and we'll divide both sides by the 208. And this will give us the time. So the time works out as 46.85 hours. Okay? Well, thank you for watching. I hope you found that useful. If you want more practice on differential equations and using the chain rule, you can download the lessons and the worksheets from my website, mrmathematics.com. I'll leave a link in the description below.